basically to distract what's irrelevant, and then finds overlaps in the index, and again, completely language independent. And by working not off of the entity of a word, you have the capability to even work in languages that are not following, alphabetic rules. It does follow word rules, so Chinese doesn't have spacing between words, and still it's text and it's interpretable.
You run into problems with such languages. And anyway, so okay.
And,
so let's get back to your product. You're announcing a product on Monday.
Well,
we can talk about the theory all day long.
Well, maybe two different aspects also about this. So, traditional view on how to deal with language analysis is I train the system, and it then knows the vocabulary set, and it then can interpret what to do with it. Okay. We don't believe in that, because again, the liveliness of language just imposes something different. Yes. So again, we're just doing the contrary. We're sort of looking at normality. If I describe you my face, I'm not going to describe the fact that I have a mouth and a nose and 2 eyes, but rather if I had 3 eyes, you would want to know, right? Yes. So the deviation from that normal case is something which we pinpoint as something very specific. Okay, that's the general view on how we deal with things. What that has given us is an infrastructure which is highly scalable. So on just one machine, we can deal between 50 to 250 million documents. Okay. Just multiply that by 10, and you have a web index. 10 machines compared to 100,000.
Yeah. Okay. So the main thing is that each time we analyze a page, we derive a profile. Everybody does that. Yes. And the normal case is that the profile which is derived has about between 50, 80, sometimes to 120, 150% of the original text. Yeah. That's a lot of profile amount. Yes. What we derive is that at least the profile in average has 1 kilobyte data. I don't want to talk too much about how it's built up, but one profile has 1 kilobyte of data. That means normally we lay around, we are between 5% of the original text.
Give me some idea of that kilobyte. What kinds of things is it?
Okay, that covers at first some patterns, maybe 200 bytes of patterns, maybe 250 bytes of maybe an abstract, and maybe some keywords just to clarify for our test purposes what is happening there. Really don't need the keywords, but it makes it a little bit more comfortable for us to test it and to see what is really happening there. Give me an idea. Maybe we can later on show off the record what is happening there, but...
you probably have hundreds of patterns where... I don't know how many, but give me an idea.
I really don't want to talk about, but really, sorry. But what I can tell you is that the pattern's not only located in one single word, for example. Yeah. They can span more than one word, and this can span a wider range. And it's a little bit like analyzing genetic code. Yes. So you have a lot of information, many parts covering no information, and other parts which have a lot of information. And to detect this is the main thing. And that Philip has just explained a little bit. So,
what kind of pattern does it look? So let's say I read a paragraph of text and put it on my blog.
Patterns that are 32 bits.
Well,
4 bytes.
But your question is what kind of patterns you
use. What's it looking for?
Well, first of all, let's say even we don't know exactly what patterns are generated. But looking at a text, we won't know exactly what the patterns will be.
But I can't read the patterns. So they are highly compressed, highly compressed, yes? And they cover and take compressed information.
So I think the effect is quite interesting. It's a system which has no intimate knowledge of language whatsoever, and it still can produce decent results. And let's maybe take a look, because again, and you can use this to actually match highly relevant stuff into unstructured environments. So take a query, and we can look into queries as well. Take a query that starts off with a certain topic, black hole, and then you add something like dentist, jaw, teeth. Suddenly that query turns, because the gravity of that query turns away from space and more into the dentist direction. Yes. Right? The results will actually adapt to that. If you then again, at the end, add things like space, wormhole, something else, suddenly the gravity again changes back to space. And that is exactly what's happening on pages. I mean, first of all, you have an overview page of Wall Street Journal. We could take a look at that too. Yeah. It's an unfocused page. It has all sorts of things on it, right? So that's not perfect. That's not the perfect query, because that's not going to be a focused query on a certain topic. But if you go to the level down, you're going to have a very focused page on a certain topic, which covers one news about a company or something like that.
I think we should show it.
Yeah, that's it.
It's much more better than
you want to move the camera over here?
Talking about the whole.
Yeah, we'll just stay on this. We'll just stay on the computer. Just give me a sense of what we can see, so you can.
So let's just first be clear what you're going to be taking.